Hi Year 11s, so this video is on second derivatives. So if you are given a function and we have the first derivative, which is f dash, then the second derivative is f dash dash. So we just find the derivative of the first derivative. And then these are the two possible notations that can be used for the second derivative. So just got one example to do. Part B will probably take us the longest, but A and C aren't too bad. So part A, we just have to find the first derivative as our first step. I'm just going to write out the function that we're starting with first. Now the first derivative of this will be, nice and easy, 8x cubed minus 3x squared plus 6x. And then to find the second derivative, we just do the derivative of that, which will be 24x squared minus 6x plus 6. So that's the second derivative. Just do the derivative again after you've done the first one. Now part B, we've got this function, f of x equals x over x squared plus 2. And we want to find the value of x for which the double derivative equals 0. So we need to find the double derivative of this function. So that's going to be the longest process we're going to have to do. So to find our double derivative, we need to find our u and v for the first one. So the u will equal x, v will equal x squared plus 2, u dash is 1, v dash is 2x. So now we put together our first derivative. So the first derivative will equal, now it's a quotient rule, so we need to do u dash v minus v dash u all over v squared. So u dash will be 1 times v, which is x squared plus 2, minus v dash, which is 2x multiplied by u, which is x, is all over v squared, so x squared plus 2 all squared. Then we can just tidy this up a bit, so we'll get x squared plus 2 minus 2x squared of x squared plus 2 all squared, which will then equal 2 minus x squared all on x squared plus 2 all squared. Now from here then, we need to do our derivative again to get the second derivative. So from this one, so we're going to look at this bit here now. Our u will equal 2 minus x squared, and our v will equal x squared plus 2 all squared. So u dash will be minus 2x, and v dash will be 4x x squared plus 2. Now that's just a chain rule, so if you need to do your intermediate steps of the chain rule, go for it. So then we're going to put together our second derivative, which is u dash times by v minus v dash times by u all divided by v squared, which will give us x squared plus 2, and the squared will give us to the power of 4. So from here, it's really having a good knowledge of factorising to know where to go. So when factorising this at the top here to be able to solve it to equal 0, what we need to look at is, you'll see between the first part, this bit here, and the second part, think about our factorising, we'll look at what we have in common. So in common, we have a minus 2x, and we have an x squared plus 2 common in both parts. And the next bracket is whatever's left. So from the first part, we still have an x plus 2 remaining. And from the second part, we're going to have a plus 2 that's left here, because minus 2x times 2 will give us a minus 4x. We've already used the x plus 2, and then we still have left a 2 minus x squared. This is also going to be over the x squared plus 2 to the power of 4. So if we look at simplifying this numerator some more, the minus 2x is going to stay, and we're going to have the x squared plus 2. Now we can simplify this part in the brackets here, and when we simplify that, you'll find we get minus x squared plus 6. And then we will still have our fraction of x squared plus 2 all to the power of 4 on the denominator. Now, the question was asking, when does the second derivative equal 0? So we want to know, when does this equal 0? Now, we can multiply the denominator to the other side, which means we're just going to end up with 0 equals minus 2x, x squared plus 2, multiplied by the negative x squared plus 6. Now this once again comes back to solving equations. For this to equal 0, either this part here, minus 2x equals 0, x squared plus 2 it has to equal 0, or minus x squared plus 6 equals 0. If any of them are 0, then the whole equation will equal 0 because they're multiplying. So we know that minus 2x may equal 0, which means x equals 0 if we solve that, or x squared plus 2 can equal 0. Now if we look at solving this, we're going to get the square root of a negative number, which isn't possible, so that one will not work. So we're just going to put a cross through that, or we're going to have minus x squared plus 6 equals 0, which means we'll get minus x squared equals minus 6, which means we get x squared equals 6, and x will equal the square root of 6. And that can be the plus or minus of the square root of 6. So our possible solutions for the second derivative to equal 0 is going to be 0, positive square root of 6, or negative square root of 6. So that is a really complicated example. The hardest part there is the factorising. So you've just got to look what you've been given. These questions you will be factorising, looking what's common, and then going from there. Okay, for part C, I've just copied in the question here. So we've got the function negative 16x squared minus 1 over x, and we want to find the double derivative at 1. So we'll do this by hand, and then I'll do it again on the calculator like I did a few videos ago, so you can see how to do it on there as well. So the first thing we need to do is find the first derivative. But what I'm going to do is write this without that fraction. So we'll have minus 16x squared minus x to the power of negative 1. Then we can do the first derivative of that, which will give us negative 32x plus x to the power of negative 2. Then we can do the second derivative of that, which will give us negative 32 minus 2x to the power of negative 3. And we want to find the second derivative at 1. So instead of x, we will just be writing 1. So we'll have negative 32 minus 2 to the power of 1 negative cubed, which will just be 1. So we'll get minus 32 minus 2, which is minus 34. Now let's have a look at it on your calculator. So to do this on our calculators, we're going to follow the same steps as we did the last time we did it. So you're going to go to menu and calculus and then numerical derivative at a point. The difference here is we're still going to have a variable of x. We're wanting to find it at 1, but we are wanting to find the second derivative. So you need to go to your menu and change it to second derivative and then press OK. Now in here, put the original equation. So it'd be the minus 16x squared minus 1 on x. Press enter and you will see you get negative 34, which is what we got when we did it by hand. Now that's that video on second derivatives. This lesson you also need to watch the next video, which is on increasing and decreasing functions, and at the end of that video I will tell you which exercises you need to do.